In these notes, you're going to be introduced to the concept we call linear programming. And linear programming is going to take the previous notes when we talked about inequalities and graphing those. And we're going to extend that to the business part of this. So in order to do that, though, let's recall what we talked about. Remember, we talked about when we solve a system graphically, a linear inequality graphically. We have those symbols. In inequality, you have the less than or equal to, greater than, or greater than or equal to signs. And your solutions based off of that were sets, or solution sets, and they were based off the shading. And remember, when you shaded the line, you can either include the bound or not include the bound. We include the bound, we have a dashed line. We have a dashed line. And so for these dashed lines, we have less than. When we include it, I'm sorry, it's a solid line. This is a solid line for these. So we have the solid line is less than or equal to or greater than or equal to. And for the exclude, we have the dash line. And we dash that's less than or greater than. And our shading was above or below. We're above the line if we have a greater than sign or a greater than or equal to. And we're below the line if we have the less than or the less than or equal to. And remember, we're always going to be above or below the y-intercept. And so when we start to graph a system now, we're going to graph a system, which means we're going to graph more than one line at a time. We're looking for the solution, or what we now call a solution region. So we're going to be within a solution region. And the region occurs from the shading overlapping. So if you look at this picture here, our solution region, we have, well, the first line is shading. This line right here, this dashed line right here, is being shaded above. You're shading above that y-intercept up here. So you're all inside of here like this. And then the other line right here, the solid line right here, is shading below. And so what you're looking for is the intersection of the two regions, which is here, this little piece. And that's going to be our solution region. So that's what we're going to focus on in this first video, all right? And so in order to solve a system of linear inequalities graphically, what you have to do again is you get the equations, both equations to y equal, and graph them. So we're going to get this first equation right here, x plus y greater than or equal to 6 to y equals. So to do that, we're going to move the x over, and we get y is less than or equal to, remember, move this x to the side, becomes negative x plus 6. So to plot that, remember, I plot the y-intercept first at 6. Slope says to go down 1 over 1. So I'm going to go down 1 over 1. And I get this line here that I'm creating. And notice that because the symbol that says shade, it's a solid line, and you're going to shade above on this one. So I'm going to extend it out like this, and I'll shade above. So my first shading occurs like this. I'm above that line like this. The other line, which is 2x minus y is greater than or equal to 0. Again, I want to get y by itself, so I'll say negative y is greater than or equal to, move the 2x over, it becomes negative 2x. Divide everything by negative 1. And remember, when you divide by negative 1, it flips signs, so I get y less than or equal to 2x. So the intercept here is at 0. That's your intercept. Slope says to go up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. I can also go down 2 over 1. Like this to get that positive slope. And here, again, your symbol is less than or equal to, so I'm going to have a solid line there. Solid line. And we're shading below that solid line. So I'm going to shade below that solid line this time. So I'm shading down here, below the y-intercept. And what I'm interested in now is this region right here that includes both the shades. So from here to here. This region out here, the overlap, is what we call our solution region. So this is the solution region here. And that means that any point in the solution region will satisfy this equation. Will satisfy this equation up here. So let's do one more. Again, I have y greater than or equal to x minus 6. So that's already in our form for us. So we'll graph that negative 6 first. Slope says to go up 1 over 1. So I'm getting this line here. And again, it's greater than or equal to, so it's a solid line here. So I'm going to make this into a solid line. And because I'm greater than, that means I'm above that y-intercept. So I'm going to shade everything up here. Everything above that line gets shaded. The other equation, y is 2x minus 4y. 2x minus y is greater than or equal to 4. So again, get y by itself. So I get negative y, move the 2x over. That's greater than or equal to negative 2x plus 4. Divide everything by a negative 1. And again, when I divide by that negative 1, the sign is going to flip. So that's y is less than or equal to, that's a positive 2x. 4 divided by negative 1 is a negative 4. So plot those points. So negative 4 is the intercept. Slope says go up 2 over 1. Up 2 over 1. Up 2 over 1. I can also go down 2 over 1, down 2 over 1, down 2, down 2 over 1, down 2 over 1. And here's the line I'm getting. And again, it's a solid line because it's equal to it. Like this. And this one says to shade below that line. So I'm going to shade below that y-intercept. I'm going to shade below the y-intercept, which is this down here. And do you see where your overlap is taking place? Well, the overlap is taking place from, looks like from here to here. It's the overlap in the sections. So this is now your solution reading. So anything inside of there will satisfy the equation.